Okay, hello students. So in this video, we will talk about integration by partial fractions. If the integrand is in the form of an algebraic fraction and the integral cannot be evaluated by simple methods, the fraction needs to be expressed in partial fraction. Okay, so a definition of proper fraction is any rational function of x in terms of px over qx, where the px is less than the degree of qx, could be expressed as sum of relatively simpler rational functions called partial fraction. Okay, maksud dia kat sini px tu kuasa untuk function px tu kurang daripada kuasa untuk function qx. Okay. Okay, untuk qx tu kita akan ada three different factors. We will have three different factors for qx. Okay, the first one is linear factor. Okay, so if the factor is linear, then we will have a1 plus a2 plus a3 and so on. Okay, the second one is repeated linear factor, which is in terms of ax plus b, and then it repeat several times. Okay, so the partial fraction, okay, a1 plus a2 plus a3 until an, okay, by repeating the degree of the linear factor. Okay, and then last one is quadratic factor, ax squared plus bx plus c. So your partial fractions will be in terms of ax plus b over ax squared plus bx plus c. No, not to be worried, we will look into this factor more when we do the examples. Okay, let's see example 1 here. You have integration of 6 over x plus 3 times with x plus 1 dx. Okay, so the qx ni part yang bawah ni sajalah. Okay, the qx is in terms of linear factor, kan? Dia ada two different linear factor. Okay, which is the factor is x plus 3 and x plus 1. Okay, so our partial fraction should be in terms of okay, let's say I choose a over x plus 3, and then another one I choose, okay, let's say the second one I choose a different alphabet, which is b, so b over x plus 1 dx, then I want to integrate this one. Okay, means we change our function into a partial fraction. Okay, so how to find the value of a and b? Okay, so I equate, saya omit dulu yang integration tu. Okay, saya ambil equation saja, so it will be in terms of this one. Okay, now saya samakan perkali di bawah. Okay, ikut the denominator, I will have x plus 3, x plus 1. Okay, so the a will be a times x plus 1, and then the b will be b times x plus 3. Okay, to make the denominator equal, right and left hand side. Okay, so what you have is your a x plus 1 plus b x plus 3 will be equals to 6, because your denominator is already the same, so we equate our numerator. Okay, so we can find the value of a and b here. Let's say I choose x equals to negative 1. If I choose x equals to negative 1, then my a will be equals to 0, and then my b will be negative 1 plus 3 equals to 6, which is 2b equals to 6, and I will have b equals to 3. And then another one, I choose my x equals to negative 3. Why I choose my x equals to negative 3? Then in this, when I choose my x equals to negative 3, my b, the alphabet b, will be equals to 0. So it's easier for me to find the value of a. So what's left is a negative 3 plus 1 equals to 6. So negative 2a equals to 6. So my a will be equals to negative 3. So what I have is 6 over x plus 3. X plus 1 is actually equal to, your a is negative 3, and then your b is 3. Okay, here will become this one. So the integration of this one is the integration of that one respect to dx. Okay, so to integrate negative 3 over x plus 3 is negative 3 ln x plus 3, and then the integration of 3 over x plus 1 will be 3 ln x plus 1 plus c. Okay, remember, whenever you integrate 1 over x, it will be ln x. So 1 over x plus 1 will be ln x plus 1, or 1 over x plus a will be ln x plus a generally. Okay, so next example, we have integration of 7x plus 6 over x cubed minus 3x squared dx. Okay, so again, this is a partial fraction. Okay, so what you have to do is you have to factorize your denominator first, because it can be factorized. So let's say I bring out the x squared, so I will have x minus 3 dx. Okay, so my denominator here, the qx here, is in terms of you have to one is the repeated linear, which is the x squared, and then the other one is the linear, different linear, which is the x minus 3. Okay, so I will have a over x plus b over x squared, because it repeated. Okay, so every time you have a repeated linear, so you have to repeat the partial fractions. Okay, for example, if I have 1 over x plus 1 to the power of 3, so the partial fraction will be a over x plus 1, b over x plus 1 to the power of 2, plus c over x plus 1 to the power of 3. Okay, repeat until the degree is done. Okay, so come back to this one. I will have c over x minus 3. Okay, so I want to integrate this one respect to dx. Now let us find the value of a, b, and c. Again, equate the denominator, then we equate our numerator. Okay, okay, so we'll have like this one. Now we can equate our numerator. 7x plus 6 is equals to ax x minus 3 plus b x minus 3 plus c x squared. Okay, so I can let my x equals to 3. If I let my x equals to 3, my a and b will be equal to 0, so I'll have 9c equals to 7 times 3 plus 6 which is 27, then c will be equals to 3. And then let's say I let my x equals to 0. So if I let my x equals to 0, my a will be equals to 0 and my c will be equals to 0. So what's left is b 0 minus 3 equals to 7 times 0 plus 6. Negative 3, b equals to 6, then b will be equals to negative 2. Okay, and then I'll let my x equals to 1. You can let your x can be anything, okay, actually, but I choose the one that will make my process easier, my process to find the value of a, b, and c easier. Okay, so if I let my x equals to 1, no variable will be equals to 0. Okay, no variable will be equals to 0, so what I have is a times 1 minus 3 is negative 2, plus b 1 minus 3 is negative 2 as well, and then 1 to the power of 2 is 1, and then c, then equals to 7 times 1 is 7, plus 6 is 13. So I have negative 2a minus 2b plus c equals to 13. Okay, I can find my a here because I already have my c equals to 3 and b equals to negative 2. Okay, so you can plug in the value, then we'll have negative 2a minus 2b becomes negative 2 already, and then c becomes 3 already, equals to 13. So I can have my a equals to negative 3. Okay, so the partial fraction will become negative 3 over x plus b is negative 2 over x squared plus c is 3 over x minus 3. So integrate this one individually, separately, gets easier to do that. Okay, so the first one will become negative 3 ln x. The second one will become plus 2 over x. Okay, the third integration is 3 ln x minus 3, and then everything plus c. Okay, why this is not the ln? Okay, because it is not in terms of x. Okay, the integration of 1 over x dx is ln. However, the integration of 1 over x squared dx is actually the integration of negative x to the power of negative 2. So this is generally algebraic function, okay, with the power of negative 2. So negative 2 plus 1, so we'll have x negative 1 over negative 1, which is negative 1 over x. Okay, so that's why it become 2 over x here. Okay, you may try this, and then if you have problems, you may ask. Okay, this is our last example, example 3. The integration of 5x squared plus 20x plus 6 divided by x to the power of 3 to x squared plus 2x squared plus x. Okay, so again, this is in terms of fraction. So we transform this fraction into a partial fraction. So okay, so first of all, let us factorize our denominator. Okay, and then this part can be factorized once more. And we will have x plus 1 to the power of 2. Okay, so the qx here, we have 2 factor, which is the first one is the linear factor, and then the other one is the repeated linear factor. Okay, so transform into partial fraction, we will have a over x plus b over x plus 1. Okay, since it is a repeated linear, so again c over x plus 1 squared. Now let us find the value of a, b and c. So I just equate the denominator and numerator. So a will be, and then b. Okay, so let's find the value of a, b and c. Let's choose x equals to 0. So choosing x equals to 0, our b and c will be equals to 0. Then we have a equals to 6. Now let's choose x equals to -1. Choosing x equals to -1, we'll leave our a equals to 0, b equals to 0, so we have negative c, which is equals to 5 times -1 squared plus 20 times 21 plus 6, which is -9. So c will be 9. And then lastly, to find b, I just choose x to be equals to 1. You can try any value of x, okay? But I choose x equals to 1. Then I will have 1 plus 1 is 2, 2 to the power of 2 is 4. So 4a plus b times 1 is b, 1 plus 1 is 2, 2b plus c equals to 31. So plug in substitute the value of a equals to 6 and c equals to 9. Then I will have my b equals to -1. Okay, so what we want to solve is 6 over x plus b is -1 over x plus 1, and then c is 9 plus 9 over x plus 1 squared x. Okay, so then say 6 ln x minus ln x plus 1 minus 9 over x plus 1 plus, okay, remember this one, it is not ln, okay, this is not ln because you have x plus 1 to the power of 2, okay, so to integrate 9 over x plus 1 to the power of 2 is actually you bring the power and it become -3 dx. Okay, so we have x plus 1 -3 plus 1 over -3 plus 9, which is -9 x plus 1 -1, then we become okay. So you have learned about 3 techniques to solve for integration, okay, the substitution by parts and partial fraction, okay, on top of the general solution, which is the using table, okay. So let's look into these four different integration. Okay, you have to know how to distinguish between all the techniques. Okay, so the first one, integration of sine x over dx. So this one is a general technique, which is the one that you can solve using the table of integration. Why? Because if you look into the table of integration, you have a integration of sine that becomes negative cos x plus c. So that's it. Okay, the one that you can use the one that you can use the one that you can solve using table of integration, then that's the general one. Okay, second one, you have integration of x sine x squared dx. Okay, so this is a product of two different function, okay, which is the x algebraic and sine x squared is the trigo. However, you don't use by parts to solve this one. Why? Because you have sine x square. Okay, you have to use however, you don't use by parts to solve for this one. Okay, why? Because you have sine x square. Okay, you just use a substitution technique. Okay, so to use substitution technique, the tips is, if you differentiate a variable or a function and you get the other function, then you use substitution techniques. Okay, for example, in this problem, if I differentiate x square here, I will have 2x. Then the 2x, I can substitute x into this one. Okay, so if I differentiate x square, I get 2x, which is there's a x in this one. Okay, so let use u equals to x squared. Then if I differentiate this one, I will have 2x, and then there's a x dx, right? So what's left on your left hand side is 1 over 2 du. So you can substitute already. So the x sine x square dx will become x square will become u, okay, and then the x dx will become 1 over 2 du. Okay, what you want to integrate is actually this one only, 1 over 2 sine u du. Okay, and then you have simplify this integration to be solved using table only. So again, if you have integration sign, it will become cos, negative cos. Okay, but then the original problem is in terms of x, so substitute back. I will have cos u is x squared plus c. Okay, the third one, okay, so much or less it looks like it is similar to our previous integration. However, now I only have sine x. Okay, it's not sine x squared, it's only sine x. Okay, so it's a product of two different function, algebraic and trigo. And in this problem, if I differentiate x, I will get 1, which is there's no 1 here. Okay, and if I differentiate x on the algebraic, then how about sine, right? So we use by parts. Okay, we don't use substitution, because if we use substitution, there's no variable to be substituted. Okay, so in by parts technique, remember this one, let LATE. Okay, let LATE, log, algebraic, trigo, and exponent. So in this case, algebraic comes first before the trigo, so u is the algebraic x, and then dv is the trigo sin x. Okay, so we differentiate the du, we will have 1, so our du is dx we integrate the dv, we'll get v, means we integrate the sine x, so we will have negative cos x. Okay, so everything will be uv minus integration of v du. U is x, v is negative cos x minus the integration of v du. Negative cos x du is dx. Okay, remember this part you still have to integrate. So I will have negative x cos x plus integration of cos is sine. Okay, last one. This one is obviously a partial fraction in terms of partial fraction. Okay, because you have a fraction there, px over qx. So you can solve this one using the technique I've told you in this video. So if you still have a problem, or you still don't know how to distinguish between all these techniques, don't forget to reach out to your lecturer. Okay.